Okay, what I'm going to start doing between now and the ACT is giving you ACT questions at the beginning of every class just for practice. So I have 3. I'm going to do 3 a day. So here's your first one. So go ahead and answer. I know you don't need to worry about it, but you get to participate.
Sweet.
Everybody have an answer?
Yes.
Yes? What'd you think?
I think it's B.
What does everybody else think?
I got C.
Got C.
Okay, it is C. Now, as we go through these questions, I'm going to start giving you some strategies. Okay? Number 1, with ACT Math, and I realize you've still got some time before you have to take it, but it doesn't hurt to take it early so that you kind of have a baseline score, and then you can take it again when it really matters after you've had it a couple times. You are allowed to use a calculator. There are 60 questions, okay, and you're given 60 minutes. So my advice to you is that the very first problem on the ACT is going to be the easiest problem. The very last problem on the ACT is going to be the hardest. It definitely goes in increasing order. Okay, I have students who have had pre-calc trig, maybe even calculus, and they still can't finish because there's not enough time. Okay, but you have the exact same point value for the first question as you do the last question. So if you can really get those first half, even the first 30, dead on right because there's stuff you know how to do, and maybe bubble in the last 10 because you run out of time, you're much better off than trying to rush through it.
Wait,
Okay.
so the first and last question are the same answers?
They're worth the same points.
Oh, okay.
Yeah. Okay. Now, there's several strategies as you go through these problems, and the very first few you should be able to get really quickly. Okay. If you're jumping to the answers and plugging them in, you're going to take too much time. Okay. If you spend more than a minute on this problem, this one shouldn't take a minute. You only have a minute average on every question. There are going to be ones coming down the pike that are going to take more time. So you've got to give yourself less time in the front so that you've got more time as you get closer to the middle and then past the middle. So the easiest way to solve this problem is just solve it. Okay? What do I need to do to undo this 3? Multiply it. So that's 5y minus 1 equals negative 18. Now how do I solve it? Add 1, right? 5y equals negative 17. Divide by 5. Y equals negative 17/5. Okay, you should be able to do that in 20-30 seconds. If you're taking a calculator and you're putting in each answer, the ones that have E for your answer, you're wasting time, and you've got to preserve that time. Okay, so. And on top of that, if you're using a calculator and you happen to forget parentheses or something like that, you're going to end up with the wrong answer. Okay, so just solve this one. That's the easiest way. All right, let's go to the next one. Hopefully this is one you can get really fast. Go.
Is that a 12?
Yep, 12. You don't even need to write it, really, do you? What do we do with the exponents when we divide?
Minus.
Subtract. And 12 over 4 is 3. 10 minus 2 is 8, so it should be 3z to the 8th. Okay, we just went over that section, so isn't it nice that you see it's actually an ACT question? Next one. You guys remember Ryan Soper?
Yeah.
He ended up taking the ACT this last time and forgot a calculator.
And he still did.
And he got a 35
something.
or something on math. Yeah.
Okay, that's for, I guess I'm fine. Oh, that's fine.
Oh, I don't even have a calculator. Why is this? This would be handy.
Again, the goal is to get these first ones in less than a minute because we've got to save our time for the end. So what does this mean? F of x equals x squared minus 18 over x plus 2.
Replace x with 12.
Yeah, f of 12, wherever there's an x, you replace it with a 12.
Correct.
And then figure it out. So 144 minus 18 is on top, 126. And 12 plus 2 is 14. Divided by 14, 9. There it is. It should take you 20 seconds. You have to understand what this is asking, though, before you can even jump in and do it. So this is function notation. This is just a fancy way of writing y. Y equals this. I want to put x in. 12 in for x everywhere there's an x and solve. Okay? All right. So we're just going to do 3 a day. Yeah. And try and build some of your ACT skills as we go. All right. So let's talk about 7.1. Let's do 7.1. We're learning how to go back and forth between a rational exponent and what that means as a root. Okay? Now, to answer your question, Tristan, a root is something with a radical.
Right.
If it's a square root, that means that the root is 2. And normally we don't write the 2.
Right.
It's just, you know, if there's no number there, there's always a 2.
Right.
Just like you know the coefficient of x when x is by itself is always 1. We don't write the 1. We don't write the 2 here. Okay? So it's 2. Now, to write a root, or to even write the square root of this number, a, as a rational exponent, are you guys watching or working? Why don't you turn your computers around, just so I know this is important. To write a root, the square root of a, as a fractional exponent, it is a to the 1/2. Okay, remember last chapter when we saw negative in front? What did the negative mean? Negative exponent. You flip it. The numerator becomes your denominator. Denominator goes to the numerator. You flip it. You don't change the sign at the base. It just means flip. When you see a number in a denominator as an exponent, you know that that's a root. Okay, so this is the square root of a. The square root of a. Okay, if I were to write a to the 3/2, this number is like if let's just do this one instead. A to the 3/1 is just a cubed, right? So the number on top, the numerator, in that exponent is always going to be a square, a cube. It's the number times itself however many times. If it's in the denominator, it's a root. So if I were to write a to the 3 halves as a root, that's what it looks like. I cube a, and then I take the square root because 2 is in the denominator. Does that make sense?
Yeah.
Okay?
Wait, okay, so you didn't put the 2 there because 2's are, because 2
It's implied.
is implied.
So let's do a to the 7/3. How would I write this as a root?
That would be, okay, do the square root symbol. And then put a, 7, and then put 3 outside.
It's a cube root of a to the 7th. Cube root of a to the 7th. Okay? Now, there are going to be times when I'm not using a. So let's do 32 to the 3/5 and evaluate it.
Okay, so 32 times the 5th power is, wow, that's a big number. 3355443.
So why did you raise it to the 5th power?
Because that's what's going to happen in those.
You're going to raise it to the 3rd power.
Right.
Not the 5th power.
Oh, yeah, because the 5th is going to go on the outside.
Whoops.
Erase it.
I know, I'm trying to. 32. Come on.
It's 327, 368.
3rd power. Come on. 5th root. Okay, so what your strategy was is to take 32 to the 3rd power and then take the 5th root of it.
Right.
Okay? My strategy is going to be different. I'm going to take the 5th root of 32 and then raise that number to the 3rd power. So what number times itself 5 times is 32? What were you going to say? Yeah? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Good guess. Okay? So there are times when it makes sense to take the root first and then raise it. Because this I could do without a calculator. The 5th root of 32 is 2. 2 cubed is 8, and I'm done. Okay? Now, I want to teach you a trick on the calculator to do roots. If I wanted to do this one on the calculator, I'm going to type in 32. I'm going to use that little caret, and I'm going to put parentheses around 3/5. Okay? So to find the cube root of something, you're going to raise that number to the 1/3 power. Right? If you ever see, what's the cube root of, I don't know, 126? And I want to know what it is to the nearest hundredth. How do you find it on the calculator?
That's not it.
126 raised to what?
3 over 1.
1 over 3.
By 3.
1/3. So to the nearest hundredth is 5.01. Because it's not a perfect cube.
Right. After I realized that it wasn't 3,
Yep.
I had to belong to the 3.
So just remember, if you ever want to find the cube root or the 4th root or the 5th root, all it is a fractional exponent. You just raise it to 1 over that root. Okay? Now, simplifying roots when you have a cube or, let me see if I can find an example. I'll just do one from the textbook. Let's do these are, so let's do this one. The cube root of 54x cubed over 125y to the 5th. Okay, so think of each one as a term. And we have the numerator as a term, 54x cubed. So I could rewrite this as 2 separate. I could break it apart if I wanted to. You don't have to. As as soon as you start doing these enough, you'll start seeing the process. But I'm looking for a number times itself 3 times that might be 54. Okay, so you could just try 54 to the 1/3. Darn it, it's a decimal. Okay, so think back to when we simplified our square roots. If I was taking the square root of 54 and I wanted to simplify it, I'm going to take the square root of 9 times the square root of 6. I'm looking for perfect squares. If I'm trying to simplify a cube root, I'm looking for perfect cubes. This is where I told you last chapter, you're going to have to start memorizing your first 5 cubes, maybe first 5 numbers to the 4th, 2 to the 4th, 3 to the 4th, 4 to the 4th, and so on. Because as you're trying to simplify these, I recognize a perfect cube that goes into that. Do you? That goes into 54? I can't. Erase. What number evenly goes into 54 that's a perfect cube? Give me your perfect cubes to 5. 1 cubed.
1 cubed, 2 cubed.
What's 1 cubed?
1.
2 cubed.
8.
3 cubed.
3 times 3, 9, 27.
Okay, does 27 go into 54? Twice.
Yeah.
Okay, so I can rewrite this as the cube root of 27 times the cube root of 2 times, what do you think the cube root of x cubed is? X, right? If I were to write this as a fraction, it's x cubed raised to the 1/3, right? And what do we do with exponents when we multiply? Multiply them. Sorry, not when we multiply, when we raise them to an exponent.
Okay.
I'd said it wrong. You were right on what I said. Yes, when we raise something to an exponent, we multiply them. What's 3 times 1/3? 1. So the cube root of x cubed is just x. Okay? So I don't even need to write the root now. I can just evaluate the x cubed. Okay? So what's the cube root of 27? 3. I cannot simplify this anymore, so it just stays. And I'm going to pull this x to the front of the radical. Okay? So this piece right here simplifies to 3x times the cube root of 2. Doesn't look simpler, but that's how you simplify it. Now, let's use the same strategy here on the next one. What is the cube root of 125? 5. And what's the cube root of y to the 5th? Well, let's break y to the 5th up into perfect cubes. Right? Y to the 5th can be broken up into y cubed times y squared. Okay, what's the cube root of y cubed? Y. And then I can't break up y squared. So I just say it's 1 over 5y times the cube, on the bottom it's going to be the cube root of y squared. That's how this simplifies. Because the cube root of 125 is 5. The cube root of y to the 5th is y times the cube root of y squared. Now I'll put all this together. My answer is going to be 5y times the cube root of y squared.
So you just put that in the denominator?
That's in the, because it was in the,
That was in the denominator.
and it stays there. So I could simplify this even further and say 3x over 5y times the cube root of 2 over y squared. You just break each piece apart as you're simplifying. Okay, if the number had been 4, then I'd be looking for 4th roots, not cube roots,
Right.
or something to the 4th power.
6, or if it was 6,
Mhm.
6 cubes.
I could rewrite this as a fraction, if I could use my board at all. Come on. I don't know why it's giving me fits today. I take the 3rd root maybe. Third. Third root of y to the fifth. Y to the fifth. Jeez Louise. Understand? I could write this as a fraction, y to the 5/3. And then I could ask myself, 3 goes into 5, how many times? 1 fully, so that's 1y, with a remainder of 2. So it's y times y to the 2/3, or y times the cube root of y squared. Okay, so you can always do it as a fraction and then go back. It's your choice which way it seems to work best for you. Okay, let's look at the textbook check. Seven one is here. Okay, the fifth root of 32 cubed in fraction form is 32 to what fraction?
The fifth root to 32, what's the number in the
5 is in the root and 3 is the exponent.
so it's going to be
3/5, 3 over 5. Yep, 32 to the 3/5. When evaluating a root of a base with an exponent, you should first evaluate the root and then the exponent. If it's like this problem, do the root first and then the exponent. You can do it either way. You'll get the same answer, but if you want to do them quickly and in your head sometimes, do the root first if you can, and then raise it to the exponent. Okay, to simplify the fourth root of a number, there must be blank of the same factor to pull out. 4. Yep, if it was the fourth root of y to the fourth, y times y times y times y, the fourth root of that is just y. Okay? Question 4. The fourth root of z to the 8th is z to what? Which is z squared. Yep, the fourth root of z to the 8th. So if you write it as a fraction and simplify, sometimes the answer will just pop out at you. Z to the 8 over 4 is just z squared. And then the last, there were 3 videos. False, there were 2. Okay. That is it. 7-1 web work is open.